been building homes since 1977. Been doing this a long time. I found this quote and I wanted to put it up here because this really distills how I feel about and why I put on these classes. You know, tell me and I forget. Boy, do I ever demonstrate that in our house on a daily basis. My wife can attest to it. Everything she says to me, I forget. But anyway, tell me and I forget, teach me and I may remember. So that's where we are here. But involve me and I learn, which I think is the real critical part. Learn by doing. I have talked to people for sometimes many, many years about getting in and doing a project, and they say, well, I don't know enough to do it. So that's not a good excuse, really. You need to step forward and do it, and all the learning and all the knowledge and all the things you need to know will miraculously appear in front of you. So that's how I learned how to build houses. My dad was a builder, and I started out writing checks in his office. So I learned who got paid roughly what in the sequence. So I learned the sequence of building. And he came in one day and he said, you're never going to learn the business like this. I said, oh, okay, what do you got in mind? Here's a plan, there's a lot over here, go build this house. Okay, so he basically took me to the end of the pier and threw me off. Sink or swim. So obviously I swam. So, but that's how I learned how to build. The first probably 3 or 4 houses I built was in conjunction with him, as he was my consultant. And I could call on him anytime I needed something. And you know, back then communication and information access was quite different in 1977. So I actually had to sit down and talk to my dad. You know? And as a kid, you know how difficult that is sometimes. But anyway, that's why I put that quote up there. Kind of harped on it a little bit. But it's one of the real important things. It's, you know, in the critical path method of scheduling, after you get your foundation in, you can't do anything else until you frame the thing. So that's putting the schedule. Work with owner builders, folks that want to build a project. You know, if you're going to build a new home, you have roughly 2 options. You have a builder build it, or you go through a program like this. So that's why I'm here. And I did build houses for 30 years, and now I'm on the other side of the fence. There are the lumber yards. That's actually where I started. It's funny, when I got out of school in Austin, the first job I got was as a loader. One of these guys, loading the trucks at the lumber yard. Like this, and this placing of material actually has some real thought behind it. They got to think about what's got to come off there first to be put on the site. So when I started building, those forklifts didn't come with any of the trucks I ever saw. And you'll see the results a few slides down the road. But then they started smartening up and saying the best way to deliver the material so it's nice and intact and neat and be placed is to use these, what they call spider forklifts. So, for the material, the first thing they do when the framers come out, they check the plans, they start measuring dimensions and doing what they call popping the lines. They have chalk lines. You see this little red line here? Yeah. That's the chalk line. They just put it down, pop it, then they've got their wall, the position of the wall, let's say. They're getting ready to set an outside wall, so they clean up around these anchor bolts that were put in during the foundation installation. Just knock down all the little pieces of concrete that might be sticking up. Then they're verifying more measurements, popping more lines. This whole process, depending on the size of the house, will take at least a half a day to a day, and is weather dependent. They pop lines in the morning and it rains in the afternoon, they got more work to do when it dries up. So, okay, then they lay out the base plates or bottom plate. A couple of different names for those. Sill plate they call them too. But you can see the color of that. That's a treated piece of lumber. Any lumber that's in contact with concrete must be treated. And any inspector worth his salt, if he sees something that's not treated, he'll note it. That's raised some walls. You can see this plate down here has got an anchor bolt sticking up through it, and that other regular plate is up here at the top. But you can sandwich those things together. That's what we had to do when we couldn't use Anthony power beams because they were 4 months off. Called the engineer and he said, instead of the 5-inch or 5.5-inch Anthony power beam thickness, put 3 of these together and put it up where that Anthony power beam was going to go. Once, after they popped the lines, they were laying out the wall. I tried to put that earlier, but it didn't come in. But this is where they're putting the walls together before they actually pull them up into place. And there they are putting it up into place. You know, there's only 3 guys pushing that wall. It's got that huge power beam in there. So it's pretty amazing what they can do. There's more first floor walls. They figured this all out by the measurements that they did with the chalk lines and the little pencil marks and stuff. They figured out before they ever bring the wall up or before they ever put the wall together that there's going to be a door opening there, a window opening over there, that type of thing. On your this is just an example of a circular or a curved wall. You look at the plan and you might wonder, well, how the heck do they do that? Well, they cut these bottom plates, especially when they get into this curve here, into small sections and then piece them together. Yeah. Put these top plates in. I don't know if you can see these little notches. That usually tells you there's going to be another wall coming out here. And they leave the top plate with a little overhang and then lay it in that little inset. The last part of the framing, which is called the cornice, I call that's like trimming out the outside of the house. But cornice, that one word really entails a number of different things. It entails the sheathing of the outside, the roof decking, and the building of the overhangs. This piece is called the soffit, this piece is called the fascia board. Y'all love steel. I have lots of debates with engineers about structural steel. And only because it entails an entirely different trade who has to come in at an entirely different time and really stops the framer from doing most of his work until that metal gets in place. But the framer has to do a certain amount of work before the steel guy can do his. So I've got some other slides, I think. Yeah. You can see this is a crawl space house. So the crawl space is down here, then the structural guy had to come in and put this configuration in for the second floor that will eventually be built on top of this crawl space floor. Does that all make sense? This is going to still go up, and then all the supports are going to go into the steel. Now, of course, the engineers do all their ciphering and their calculations to figure out engineered wood isn't going to handle that. We have to put steel in. There's more of it. So they were able to use the engineered beams here, but when this got into this open space, they probably calculated more of a weight factor. So then you got to put the steel in there. This is just some shots of an actual house. I was working with a client in Bel Air, and they're trying to get the steel posts and the steel supports right where they need to be. So we stood out there, and I got a call from the client. He said the framers and the steel guys are trying to figure this out. So you'll see me in the picture a little bit later. I came out there and we looked at what needed to be done. And the issue is this support right here needed to be on top of one of the concrete piers that was holding up the crawl space. So the concrete pier is right down below this thing here. So they're cutting out some blocks of wood so they can actually get this thing and place it on that concrete. It's a little tricky.
Well, that's connected to the foundation, the bottom.
Yeah.
Okay.
Right. But the concrete is on top of a pier that was drilled down. That's the foundation class.
Oh, sorry.
That's all right. There we are, all trying to figure this thing out. Those are all the metal guys and some framers and me. Yep. Now he's trying to cut out some bolts so he can get some of these plates in so that this thing can sit on top of the plate. Dreams about barndominiums. With the price of steel these days, just dream about them. But they are very expensive. First you gotta build the steel structure, the steel skeleton. Then you build the frame walls inside. And that's what they're doing right here. This was a house up in Waller. I don't know how many people are familiar with pole framing. I wasn't until about a year and a half ago. Maybe it was even more than that. And actually a client is the one who found the pole frame method. But see the house over there, that's the house that he lives in. But he wanted 2,400 extra square feet so he could bring his mother and his mother-in-law, everybody live in the area. So they built this pole frame structure. And what they do, all the structure is supported by these 4x, or what these were 6x6 posts in here. What they do is they come in and first they put these posts in, and then these are just braces to hold it in place. And then they come along and put these in place to hold those posts. And then they go from there. They'll probably have 2 or 3 rows of these horizontals going up to hold everything nice and tight. And then they put roof trusses on top of that. They can do this pole frame, they can put the whole thing together in about 2 weeks if they have good weather.
Is that cheaper?
Yes.
There's no foundation?
Yeah. Not there. They'll eventually come back and pour 4 inches of concrete in here.
That's what we're doing.
It's a fireplace. This goes in during the framing. This is specifically called an isocurrent fireplace. This is kind of a, I don't know what you call it, prefab. They come out in pieces.
Yes.
It's an amazing thing to watch. I had a client in Hunters Creek that put 5 of these things in his house. 2 of them were upstairs. Why? And typically the rafters will be nice pieces of wood. I don't see anybody using anything but number 2 rafters. If you get into a real cost push, you can go to number 3. The strength of a roof is in the bracing, not in the pieces, the individual pieces. There's another shot. That's a dormer, a framed roof. The hip rafter here, the valley, which is, when the rain comes down and hits this, its peak come down here and then it runs down the valley. And then this one is just a ridge over here. So get into some fancy framing inside the house, building a barrel ceiling. These things are amazing to watch. They cut these pieces of plywood and put them in place and then fill in the 2x. And that's the finished product after they trimmed it all out. Living in the house. I don't know. Personally, that's a lot of money to put up. The little finish off stuff that the framer will do. You'll always see that cabinet blocking, and if you don't, then you put it on his little punch list. But hurricane clips. Again, the engineer that designs the structure will specify where these go, how many go in, that type of thing. There's another foundation bolt. We're kind of getting into windstorm stuff. There's OSB, that's the common product. Every once in a while you'll see somebody shell out the extra money for plywood. What I revert back to is every engineer I've ever talked to says this tests out just as well as plywood. So anyway, personal preference, I like OSB. This guy, he really dug into everything that he did on this project. But I just talked to him a couple of weeks ago, and he has his house on the market. He was selling his house, but apparently because he wanted to get the equity out of the project. When he finished the project, I think he had something like $400,000 to $500,000 equity in the house.
Whoa.
So the value of the house versus what he spent on it That was the,
Oh, well, until it has